Hi Year 10s and welcome to our second video on coordinate geometry. Today we're going to be talking about points on lines and how we know that a point lies on a line. So basically, a point lies on a line if its coordinates satisfy the equation of the line. You know how we always have equations that look like this, y equals 2x plus 3. How are we going to work out if a point lies on that line? That's what we're going to talk about. So we have an example. To determine whether 7 lies on the line y equals 2x plus 1. We know what y is in this example. Y is 7. So if this point lies on this line, when we substitute in 3 for x, we should get 7. Alright, let's see if it works. So when x equals 3, we have y, change colour, y is going to equal 2, now I'm going to substitute in 3 for x, times 3 plus 1. So y is going to equal 6 plus 1, which equals 7, which is what we want. So we can say, so 3, 7 does lie on the line. Not a hard skill, hopefully. Now let's do another one. Let's determine whether 4, negative 2 lies on 5x plus 3y equals 16. So this time, we don't have y equals something. We have it in general form, so we're having to substitute in both points. So let's substitute x equals 4 and y equals negative 2. And we're going to get 5 times 4 plus 3 times negative 2, which is going to equal 20, take 6, which is equal to 14. So what have we done? Well, we've substituted in 4 for x and negative 2 for y. And we've found out that when we do that, we actually get 14. Problem is, 14 is not equal to 16. They're not equal to each other. I hope you agree with me that they're not equal to each other. So that is not equal to 16, and you can write that 14 is not equal to 16 because it should if that point lies on that line. So therefore, also 4, negative 2 does not lie on the line. Let's do another example. We're going to find C now. So this time, we're not actually seeing whether the point lies on the line. We've been given a point on the line. What do we not know? If you look at this and compare this to y equals mx plus c, we don't know the y-intercept, and we want to find that. Remember, when you're trying to find a value, you've got to have the same number of equations as you do have unknowns. So if we look at y equals 4x plus c, we don't know what y is, we don't know what x is, we don't know what c is. We've got 3 unknowns. But we've been given this point, 5, negative 2. So that tells us what x is, and that tells us what y is. So then we'd be able to find c. So what we can do is substitute in x equals 5 and y equals negative 2. And we are going to get that y is going to equal, instead of y, I'm going to write what y is. Y is negative 2. I just said I'd do that. So negative 2 is going to equal 4 times, instead of x, we're going to put 5. So 4 times 5 plus c. So therefore, negative 2 is going to equal 20 plus c. I want to find c, so I need to get rid of the plus 20. So I'm going to take 20 from both sides. And I'm going to get that negative 22 is equal to c. Or I can write that as c equals negative 22. Means exactly the same thing. One final example, very similar to the last one. Find k given that 4, 7 lies on the line. That's a bit of a typo. That should be lies on the line 3x take 2y equals 6. Okay, what do you think you're going to do? You're going to substitute in what x is and what y is, and then you'll be able to find what k is. So sub in x equals 4 and y equals 7. So we're going to get that 3 times 4, take 2 times 7 equals k. 3 times 4 is 12, 2 times 7 is 14, so that's going to equal k, which means that k is going to equal -2. Alright, so remember that when you've got the coordinates of a point AB, A is the equivalent of x, B is the equivalent of y. And then you'll be done.